Bright Tuty. Every student matters.
Hello students, my name is Sanjay Jain. Let us start a new chapter today, lines and angles. Lines and angles. Every one of us know what is a line, right? It extends up to infinity on both sides. That is why these arrow marks on both sides, right? And if we talk about a finite length line, it is known as line segment, right? And if it starts from a point and goes on the other side up to infinity, then we call it a ray, right? Then there can be different kinds of lines, like intersecting lines, right? These two lines are intersecting lines and they can intersect maximum on one point. If there are two different lines, you can have maximum one point of intersection, right? Lines can be coinciding. For example, these two lines, these lines are superposed on each other, right? They lie on each other. Essentially, these are the same line, right? So one line superposed on the other, they are coincident lines. These are intersecting lines, and then there can be parallel lines. Parallel lines. Parallel lines will never meet each other, right? And they will maintain this constant distance everywhere. Okay, so these are three types of lines. Now, about intersecting lines, if there are two different lines, right, distinct lines, because these coincident lines are same line, right? So these have infinite number of points of intersection, because these are infinite points that lie on both the lines. But in case of different lines, two different lines can have maximum one point of intersection. Similarly, you can talk about three lines. Let us say you have got three different lines. What are the maximum points of intersection? 1, 2, 3, right? Two lines will have 3 points of intersection maximum. And if there is fourth line, what will happen is it will give us 3 more points of intersection. 1, 2, 3. So what did we observe? Two lines, we had 1 point of intersection, When there was third line, so 3 lines total, gave us 3 points of intersection. And when I say lines, I mean distinct lines, right? Not the coincident ones. So 3 lines gave me 3 points of intersection. 3 points of intersection. 4 lines. Now this fourth line brought 3 new points of intersection. So 3 plus 3, 6 points of intersection. Right? Similarly, 5 lines. Now this fifth line will intersect the 4 lines that we already have. So it will bring 4 more points of intersection. So it will have 6 plus 4, 10 points of intersection. And you can keep on extending this logic and find the points of intersection for as many lines as you want. Okay? So this is one thing about lines. And when there are these two parallel lines, we draw a line cutting these two parallel lines like this. This is known as transversal. Okay, this is the transversal. Now let us talk about angles. Let us say two lines, two rays in fact, starting from the same initial point. Okay, so this is angle. This is an angle, and angle we always measure in anti-clockwise direction. What is the unit that we use to denote an angle? It is degree. Okay. Then we have minutes, seconds, etc., which we will study later. But the standard unit is degree. Okay. And for your knowledge, angles can be of various types, right? This angle, when there is a straight line and an angle on one side, is known as straight angle. Okay. And you know that the total angle about a point is 360 degree. So, on one side we will have 180 degrees and on the other we have 180 degrees. So, straight angle is basically of 180 degrees. Okay. So, let us discuss about some more angles. If this line is perpendicular to this line, this angle is a right angle and it is 90 degrees. So, 90 degrees angle is a right angle, and when the angle is between 0 to 90 degrees, right, that angle is known as acute angle. All right. And an angle, let us say this is the right angle. Okay. If you draw this ray here starting from the same initial point, then this angle here is more than 90 degrees, right, but it is lesser than 180 degrees. Okay. So, angles more than 90 degrees and less than 180 degrees are known as obtuse angles. For example, 120 degrees, 135 degrees, etc. Right. But when the angle is 180 degrees, it will become a straight angle. And we can also have angles more than 180 degrees. For example, if this is one ray and you draw this ray like this, then this angle is known as reflex angle. Now, this angle is more than 180 degrees, right? And if you notice, there is this another angle here, this, right? Now, this angle is more than 180 degrees. Okay. So, this angle will be lesser than 180 degrees, and this angle is known as the reflex of this angle. Okay. So, if we are supposed to calculate reflex of an angle, we know what we want to calculate here, right. So, this is what we need to calculate. For example, if you have got, let us say, this angle and you want to calculate its reflex angle. So, what we are talking about here is we need to calculate this one. Okay. And we can simply calculate it by subtracting it from 360 degrees. Let us say this angle is theta. Okay. So, what will be this angle? This will be 360 degrees minus theta. Okay. So, these are some basic terminologies, and if you draw two intersecting lines like this, these two angles are known as vertically opposite angles. Vertically opposite angles. Okay. So, let us discuss some of the important concepts here. If a ray stands on a line, then the sum of the two adjacent angles so formed is 180 degrees. To start this theorem, let us understand what are adjacent angles. Adjacent angles, let us say there is this ray and we make an angle here, this is an angle, and we make another angle here. These two angles are adjacent angles. Now, what are the properties? That these two angles will have a common arm, okay, and these will have uncommon arms, on either side of common arm, on either side of common arm, right. They should not be on the same side of this common arm. Okay. In that case, these will not be known as adjacent angles. So, there should be a common arm and there should be uncommon arms on either side of the common arm. What is the third property that needs to be satisfied? That they should have same vertex. This is known as vertex. They should have same vertex, or the rays should originate from the same point, right? Then these two angles are known as adjacent angles. Now if I ask you, let us say this is the point and this is one ray, this is another ray, and let's make this third ray. If you need to comment about these two angles, one this and second this one, are these adjacent angles? Let us look at the properties. They have a common point which they are originating from, right? And they have a common arm, that is this one is the common arm. But now you see, these are uncommon arms, this one and this one. They lie on the same side of the common arm. Hence these two angles, let us name them theta, alpha. Theta and alpha are not adjacent angles. Right? I hope you understood this concept. So these are the properties that need to be satisfied for the two angles to be adjacent angles. Now, if a ray stands on a line, then the sum of two adjacent angles so formed is 180 degrees. The question is, let us say this is a line and a ray stands on a line. So this is the ray, okay? And what are the adjacent angles? This one and this one. So let's name it as x and this as y. Okay, we can name these angles like this. Otherwise, if we name these points, let us say A, B, C and D. What is angle x? Angle x is angle A, B and D. We have denoted it by x for the sake of simplicity. So let us say this is x, this is y. Now sum of x plus y is 180 degrees. This is what we need to prove or what we need to observe here. How will we prove that? Let us say we draw a perpendicular on this given line AC. Okay. Now we know that this angle is 90 degrees. Okay. Let's name this point as E. Okay. Or what we can do is we can name this angle as some other angle. Let us name it as theta. Okay. Now see, what is angle x? Angle x is 90 degrees minus this theta. So it is 90 minus theta, right? Now talk about angle y. What is angle y? What is angle y? Angle y is, this angle is also 90 degrees, right? So angle y is 90 plus this angle. So angle y is 90 plus theta. Okay. Now if I add these two, x plus y will be equal to 90 minus theta plus 90 plus theta. Theta can be cancelled, so it is equal to 180 degrees. Okay. So if a ray stands on a line, then the sum of two adjacent angles formed is 180 degrees. Okay. And the angles, two angles where the sum is 180 degrees are known as supplementary angles. These are known as supplementary angles. So if a ray stands on a line, the adjacent angles are supplementary. Okay, this is one thing. Another type of angles can be defined as complementary angles. Complementary angles. What are complementary angles? The sum of two angles. If the sum is 90 degrees, then these are complementary angles. So if I say one angle is 30 degrees, so you will say that 60 degree is a complementary angle to 30 degrees and this is complementary to this because their sum is 90 degrees. So if I have a right angle, okay, and I draw another ray here, if this angle is theta, this angle is alpha, then theta plus alpha is 90 degrees, right? And theta and alpha are complementary angles. Right? I will sometimes denote angles by this and then writing S here. So this is angles. Okay. if the sum of two adjacent angles is 180 degrees, then the non-common arms of the angle form a line. The question is, if this is angle x and this is angle y, and it is given that x plus y is 180 degrees, then this line AC is a straight line. This is a question. Now, what we can do is, we can prove it by contradiction. Let us take another line C dash. Okay. Let us say that AC is not a straight line. Okay. Then AC dash is a straight line. Okay. If AC is not a straight line, we have drawn C dash such that AC dash becomes a straight line, right? And this is another angle, let us say theta. Now we know that this is a ray which stands on a line AC dash, so y plus theta is equal to 180 degrees. We just proved it in the previous theorem, right? But we know that x plus y is 180 degrees. So comparing these two, we can say y is equal to, we can cancel y from this, so we can say x is equal to theta, right? But x and theta are two different angles. X can be equal to theta only when C and C dash are the same points, or C and C dash coincide each other, they lie on each other. That means they are the same point. So by contradiction, we have proved that if the sum of adjacent angles is 180 degrees, the ray on which they are made is a straight line. Okay. If two lines intersect each other, then vertically opposite angles are equal. Let us say these are two different lines. These intersect each other at this point. Okay. This is one angle theta, this is another angle, let us say alpha, and let it be third angle x. Okay. So these are two straight lines, it is already given, and let us consider this line AB first. Okay. This ray stands on line AB. Let us name these also, O, C, D. So ray OD stands on line AB. Hence, adjacent angles theta plus x will be equal to 180 degrees. This is what we studied till now. Look at the another thing, line CD. Ray OB stands on line CD, right? So the adjacent angles alpha plus x will be equal to 180 degrees using the same theorem that we just proved. Now compare these two, 1 and 2. Comparing 1 and 2, we can say that theta is equal to alpha. Theta is equal to alpha, right? So this angle will be equal to this angle. Similarly, we can prove that this angle, if I name it as y, it will be equal to this angle. And these angles are vertically opposite angles. So vertically opposite angles in case of two intersecting lines are equal to each other. Okay. The sum of all the angles at a point and on the same side of a line is supplementary. Let us take a line, and on one side of this line, let us make these angles 1, 2, 3. Okay. You can make as many angles as you want, but I have made 3 angles here. Now, if this is angle theta, okay, this is angle alpha, this is angle beta, and this is angle x, let us say. Okay. So now this is a line, let us say this is line AB, okay, and this is a ray standing on this line OD. Okay, so OD stands on line AB. So we can say that sum of these angles, this angle theta plus this angle, is going to be equal to 180. So theta plus this entire angle, what is the name of this angle? AOD. Angle AOD is equal to 180 degrees, right? Now angle AOD consists of these three portions, alpha, beta and x. So theta plus alpha plus beta plus x is equal to 180 degrees. Okay, so you can make as many angles as you want on one side of a line, and the sum of these angles is going to be equal to 180 degrees. This is what this theorem says. Sum of all the angles around a point is 360 degrees. This is a similar question, right? So if I make angles around this point, right? So this sum of all these angles is 360 degrees. Let us say this is angle 1, this is 2, this is 3, 4, 5 and 6. Okay, so what this question says is that angle 1, angle 2, it is equal to 360 degrees. Okay, how can we prove that? We just proved that angles on the same side of a line are supplementary. That means their sum is 180 degrees. So angle 1 plus angle 2 plus angle 3 is 180 degrees. Similarly, we can say angle 4 plus angle 5 plus angle 6 is 180 degrees, right? And now if you add these, you will get the desired result. So this is how we can say that angles around a point, the sum is 360 degrees. Let's do these questions so we will understand this chapter clearly.